It's only in my head. Oh, and we're live.
And we are live. Welcome, party people, to Astronomy and Tap number 28.
Wow. It's been over 2 years.
Time
That
flies.
is something. Yeah. Right. Well, we are your hosts for the evening. I am MC M33.
And I am the Cosmic Kid.
And as per usual, before we begin, some announcements. There we go.
So we are still doing trivia, first of all. So you can fill out the trivia form at tx.ag/AOT trivia. There's a link in the description if you check out the YouTube channel and check it out. You can just fill out the Google form, and then at the very end of the show, we'll reveal the answers. You could win some prizes.
Smash that like button and also that subscribe button, because if you do that, at least the subscribe button, you will be notified whenever we have a stream. And also, if we get to 100 subscribers, our link becomes customizable, and we would very much appreciate that. They're fun little YouTube insider stuff for you.
Yeah, and make sure to follow us on social media at AoT_BCS on Twitter and at AoT BCS on Facebook and Instagram, or check out the website at astronomyandtap.org/events.
Great. Please support what would normally be our venue, the Grand Stafford Theater in downtown Bryan. Astronomy on Tap in Austin recently lost their venue, the North Door, because of COVID-related issues. So please don't let that happen to the Grand Stafford. You can Venmo at Jose-Quintana-20 and put Stafford Tip in the description so he knows what it's for.
Yep. And if you want to help us and support us, you can help us run the show by donating to us at AoT BCS on Venmo with Cash App. And if you get us $15, we'll mail you an AoT t-shirt.
Our next event will be on October 21st. It's always, well, almost always the third Wednesday of every month. Speakers TBD. Follow us on our social media to find out.
And make sure to put your questions to the live chats. Don't wait and forget, because you're going to forget when you get all excited about the new space news as they keep coming up. So make sure to put it in, and we'll try to get to all of them as soon as we can after the talks. And with that, I would like to go ahead and announce our very first speaker of tonight. He is Mr. Jonathan Cohn, aka Mr. MC. So John, what are you drinking tonight?
See, tonight I've got a beer called Seven Spanish Angels. This is a coffee ale, and it is delicious.
I do enjoy that ale. So fun fact about John, he actually figure skated and played violin for over 10 years. However, he has yet to do both at the same time. John, what's the holdup?
Violins are expensive, and if you fall on them when you figure skate, it would probably be pretty bad.
Well, if you can figure skate properly, then you won't fall on them.
I never said I could figure skate properly.
Well, that's fair. All right, take it away, Mr. MC.
All right. All right, so hi everyone, my name is Jonathan Cohn, and today I'll be talking about space exploration. So shown here on my title slide is one of my favorite pictures, which some of you may recognize as the pale blue dot. It's a picture taken of Earth by the Voyager 1 space probe and popularized by Carl Sagan. And I'm going to start my talk here, on that pale blue dot, because if we want to understand the course of actions that people take, it's important to understand the history that has brought us to where we reside. And although tonight's event is streamed on the internet, Astronomy on Tap BCS is hosted from Bryan College Station, which exists on traditional Tonkawa land. The government forcibly relocated the Tonkawa to Fort Griffin in 1859 and moved them to their present reservation in Oklahoma in 1884. The Brazos County region was also the traditional land of the Attakapai Shak people, particularly the Bidai. About half the Bidais were killed in an epidemic in the 1770s after contact with European colonizers. And the Texas state government forcibly removed the few remaining Bidais in 1854. It's also important to acknowledge that the United States of America is built on racist institutions that remain prevalent to this day, and academia is no exception. Black, Indigenous, and people of color face constant microaggressions, outright discrimination, and institutionalized white supremacy within and outside academia. Science and exploration are not apolitical, and they never have been. and it's our duty to demand justice and to demand that Black lives matter. All right, this talk is divided into 3 sections. First, I'm going to talk about the context of space exploration. So we'll use this context to help us understand the motivations behind why humans go to space. In the second part, I'll give a brief overview of the history of space exploration, and I'll conclude with a look at what lies in the future. But first, to understand our motives for exploring space, we have to understand the historical context surrounding exploration. The earliest documented efforts of human exploration are from long after people had migrated throughout the world. In fact, archaeologists have found evidence that humans had spread to every continent except Antarctica by 10,000 years ago, and that's what's shown on this map. Of course, more recent events will more strongly inform the way we view exploration. One of the most culturally significant events from the Western Hemisphere was the European Age of Discovery. This spanned roughly the late 1400s to mid-1600s, and the voyages of this era were largely driven by the desire of European nations to find new trade routes and gain economic advantages over their local rivals. The era's name, of course, is a misnomer. The Europeans may have found lands of which they were previously unaware, but as shown in the previous map, those lands had already been home to humans for 10,000 years or more. Still, the European explorers claimed ownership of the land they encountered, and they enslaved, extorted, and massacred the people who were there first. And this is vital to understand the foundations of the United States. The American colonies were founded as part of this race for resources and territory, which tends to come at the expense of human lives. And after the United States won their independence from Britain, many of its citizens believed it was the country's manifest destiny to expand westward. That expansion was politically contested, but it was clearly built on the foundation of European colonialism. And if you look at the map of the United States shown here, you can see that most of the modern country was either purchased or taken from other European powers, even though the majority of the land at the time was actually still held by Native American nations. Now, these maps show the seizure of lands from indigenous Americans by white settlers. And one of the most striking maps we're going to look at here is in the top left from 1850. So this is the map at 1850. And if we flash back to the previous slide, almost the entirety of the present day lower 48 states had been claimed by the United States by 1850, as we can see here. But despite those claims, the vast majority of the land wasn't under white settlers' control. And within a few decades, they had nevertheless taken almost all of that land and forced the surviving indigenous people onto reservations. And I'm not showing you this to try to make you upset or make you angry. I'm showing you this because historical context is important. It has lasting effects on world events, even with respect to space exploration and astronomy. We already looked at the western expansion of the contiguous United States, but let's not forget Alaska and Hawaii. Hawaii is particularly important for astronomy because it hosts a number of telescopes. Hawaii was its own sovereign kingdom until 1893, when settlers, led by white business leaders and the United States minister to Hawaii, overthrew the indigenous government by force. Now, even the United States government itself declared that this coup was not legal, but the United States annexed Hawaii anyway in 1898. And this has had lasting consequences. Mauna Kea, a dormant volcano and sacred site to Native Hawaiians, also serves as a site for telescopes, including the not yet constructed 30-meter telescope, or TMT. Over the last several years, protesters have attempted to prevent the TMT's construction on the sacred land that white settlers illegally took from the Hawaiian people. Astronomers often argue that the TMT will create jobs and opportunities for the people of Hawaii. But for many protesters, this isn't a conflict of science versus religion, it's a conflict of colonialism versus sovereignty, and the rights of a people to determine what happens with their land. So now, as I move on to talk about the history and future of space exploration, it's vital to remember the context in which that exploration took place and the lasting consequences of our choices in exploring the universe, both on and outside of Earth. So space exploration began with simple observations of the sky. In fact, as long as history, written or oral, has been passed down, humans have looked to space in wonder and in search of meaning. But I'm going to kind of skip over the vast majority of early astronomy because it wasn't until the 20th century that technology made traveling to space a true possibility. So I'm going to start here by highlighting a couple of early rocket scientists from the 1900s. So one of the foremost pioneers of rocket theory was the Russian scientist Konstantin Tsiolkovsky, shown here on the left. And he calculated that the horizontal speed required to maintain orbit around Earth in 1903. Later, in 1926, the American scientist Robert H. Goddard, shown on the right, launched the world's first liquid fueled rocket. So both of them listed science fiction as an inspiration, with Tsiolkovsky inspired by the work of Jules Verne and Goddard by H.G. Wells' The War of the Worlds. But this imaginative curiosity wasn't the only motivation for Tsiolkovsky. He was born into the expanding Russian Empire, and he believed further that humanity would one day colonize the entire Milky Way galaxy itself. So with developments in rocket technology that happened in the early 1900s, the world was poised for the onset of space travel. In the burgeoning Cold War, the United States and Soviet Union engaged in a well-publicized nuclear arms race as they sought to extend their influence over other nations throughout the world. Now, world powers have long played these games of imperialism and colonialism, but the 20th century saw the search for strategic advantages turn to space for the very first time. And this is where space exploration truly began, with the space race. In this period, while individual motivations may have included curiosity and awe for the universe, the actions of both the United States and the USSR were driven by textbook colonialism, a desire to extend their spheres of influence and gain material and tactical advantages over each other. So the United States' most famous accomplishment from this era is to put the first man on the moon in 1969. So during the Apollo 11 mission, the United States' Neil Armstrong and Buzz Aldrin, whose footprint is shown at center, walked on the moon. Apollos 12, 14, 15, 16, and 17 followed, for a total of 12 astronauts to walk the surface of our satellite. The last 3 Apollo missions also carried lunar rovers to the moon, and pictured at bottom left is the astronaut Eugene Cernan of Apollo 17, the final Apollo mission on a lunar rover. Of course, one of the most iconic symbols of 20th century space exploration is the United States Space Shuttle. To date, the space shuttles are the only reusable crewed spacecraft to make multiple trips into orbit. They carried out myriad missions, including carrying segments and crew up to the International Space Station. Highlight for astronomers, they also carried out servicing missions on the Hubble Space Telescope, shown here at right. The Space Shuttle program is unfortunately also infamous for the tragic destruction of 2 shuttles and the deaths of their crews, the Challenger at the top left and the Columbia at the bottom left. In both incidents, the flaws in the shuttles were actually identified ahead of time, but NASA managers disregarded them or considered them not likely possible to fix. Now, throughout all of this, the United States wasn't exploring space alone. The space age was driven by competition between the United States and the Soviet Union. And the Soviet Union claimed their share of firsts too. They famously launched Sputnik 1, the first artificial satellite, shown at left, into orbit around Earth in 1957. They also put the first mammal in orbit, a dog named Laika, shown at center, that same year. And in 1958, the Soviet Union launched Luna 1, shown at right. This was the first probe to reach escape velocity. In other words, it was the first to escape Earth's gravitational pull. And while the United States won the race to the moon, the Soviet Union turned to creating space stations with the Salyut program. They launched the first space station, Salyut 1, in 1971, and this is pictured over at bottom left. Shown in the top left are the crew of the Soviet Union's Soyuz 11 mission. These were the first people to crew a space station in orbit. They were also tragically killed when a pressure valve in the Soyuz 11 reentry capsule opened prematurely. And to date, they remain the only people to have actually died in space. Before long, as part of the detente in the Cold War, in 1975, the Soviet Union and United States undertook the first ever international space mission, in which an Apollo crewed spacecraft docked with a Soyuz crewed spacecraft. And this is pictured at right here, where we have the cosmonaut Alexei Leonov with the astronaut Deke Slayton during the mission. And this mission is sort of considered a formal end to the space race. And I want you to take a moment here to consider this absolute surge of progress that we saw in just a few decades. And while the space race inspired admiration and wonder, and increased spending on education and science in both the United States and Soviet Union, it's still important to remember that at the heart of all of this exploration were 2 superpowers competing for national security advantages over the other, and using space exploration as propaganda, such as in the propaganda images shown here. All right, in the years since the space race, while competition has continued, there's also been increased cooperation. And there's perhaps no greater symbol for this cooperation than the International Space Station. And the space station sort of lives up to its name as a collaboration between space agencies from the United States, Russia, Japan, Europe, and Canada. The ISS has been continuously crewed since 2000. It's actually coming up on its 20th anniversary, and it's served as an important laboratory to conduct scientific experiments in space. Now, up to this point, I've focused on missions to Earth's orbit and the moon, but we've also launched myriad probes and rovers to explore the rest of our solar system. The Soviet Venera 7 probe, which landed on Venus in 1970, was the first to land on another planet. A few of my favorite images from our solar system are also shown here. So we have a beautiful image of Saturn, which was given to us by Cassini-Huygens, which launched in 1997. On the top left, I'm showing Curiosity, perhaps the most famous of the several Mars rovers, which landed in 2012 and remains active to this day. Most of you will also likely recall in 2015 when the New Horizons probe flew by Pluto and took this iconic picture of the dwarf planet with a little heart on it there, adorable. And the picture at the bottom right, taken by Voyager 1 in 1979, shows a volcanic plume on Io, one of the many moons of Jupiter. And this plume was groundbreaking because it was the first time we saw volcanic activity on another body outside of Earth. And if we're talking about space exploration, we really have to talk more about Voyager. Voyager 1 launched in 1977 and took the pale blue dot image shown again at left. And it's currently the farthest human-made object from Earth. In fact, in 2012, Voyager 1 crossed something called the heliopause. This is the boundary where the sun's solar wind, which is a stream of charged particles that are sort of like emitted from the sun, gets balanced out by stellar winds from other surrounding stars. So as Voyager 1 was specifically sent outside the solar system, NASA also rather optimistically included a copy of the Golden Record on board in case it should ever be found by extraterrestrials. This record holds photographs and sounds from Earth, greetings in 55 languages, and a broad collection of music ranging from Beethoven to Chuck Berry. It also contains significant scientific information, including a map showing the sun's location relative to pulsars in the Milky Way. Of course, humans don't just want to send things to other worlds. We've long dreamed of sort of traveling to those worlds ourselves. And it turns out that exoplanets, or planets orbiting stars other than our sun, are common. We've already identified more than 4,000 of them. And we're finding that many of them actually orbit their star at the right distance for liquid water to exist. Of course, just because liquid water could exist on a planet doesn't mean that it does, or that the world would actually be habitable for humans. This also depends on things like the planet's mass, its composition and atmosphere, and the behavior of the star it orbits. But shown here is a list of 21 plausibly habitable exoplanets that we've identified, ordered by their distance from our solar system. And the closest is actually Proxima Centauri b, which orbits the red dwarf star Proxima Centauri, which is actually the closest star to the sun itself. Okay, so there's a lot there that I didn't have time for, but that's a rough summary of some of our space exploration efforts up to this point. So now, what does the future hold? I'll mention a few planned missions for the near future, and then I'll talk about some of the more speculative ways we could explore space. Recently, some nations outside the United States and Russia have also been building up their space programs. India and Iran both have ongoing programs in development to launch astronauts into space for the first time. India's Gaganyaan mission, with a poster shown at right, is planned to launch in December 2021. There are also a number of commercial programs in development, including with Boeing and perhaps most prominently, SpaceX. Boeing's Starliner at top left and SpaceX's Dragon, shown at bottom left, are both contracted to carry crew for NASA. And right now, NASA's biggest project is Artemis. This is a mission with the goal of returning astronauts to the moon, including the first woman to set foot on the moon. NASA is leading the mission in partnership with the European, Japanese, Canadian, and Australian space agencies. And this Artemis project will be supported by a mini space station orbiting the moon called the Lunar Gateway. Part of this mission is also to set up the Artemis Base Camp, a habitat on the moon, by the end of the 2020s. Now, the Artemis program has come under some criticism for its design, with some such as Buzz Aldrin questioning the need or use of the Lunar Gateway. NASA currently has plans too to put humans on Mars in the 2030s, but I'm not going to go into much detail about the planned Mars missions because Taylor has an excellent talk coming up about Mars planned for our second presentation this evening. So another open field of space exploration is mining, especially asteroid mining. There are lots of motivations for mining in space, including resource scarcity on Earth. Resources gathered in space could also be used for fuel or infrastructure in space, which could drastically reduce the cost of space exploration. Still, the financial feasibility of asteroid mining is uncertain. And furthermore, due to the ambiguity in the Outer Space Treaty, there's some uncertainty regarding the legality of mining asteroids for profit. And this sort of resource gathering is also exactly the type of situation where people have historically damaged the environment and acted against human interests or violated human rights in the name of profit. We'll have to learn from our history on Earth to protect both human rights and the environment as this sector develops in the future. So pictured here, I have a couple ongoing missions to asteroids to gather asteroid surface samples. On the left, we see the first image ever taken from the surface of an asteroid on Ryugu during Japan's Hayabusa 2 mission. Hayabusa is expected to return to Earth this December. And at right, I have an image of the asteroid Bennu on approach of NASA's OSIRIS-REx mission, which should return to Earth in almost exactly 3 years. All right, so I've talked some now about exploring the solar system, but what about future plans for exploring outside the solar system? There are no firm plans, but scientists have long speculated on the possibilities of interstellar travel. The most important difficulty facing interstellar travel is the vast distance that must be traversed. Even the closest star, Proxima Centauri, shown here, is more than 4 light years away. In other words, even if we could travel at the speed of light, which we can't, it would take more than 4 years to get to Proxima Centauri. The fastest spacecraft ever launched, the Parker Solar Probe, is planned to reach almost 430,000 miles per hour, which sounds really fast, but that's still less than 0.1% the speed of light. And sending humans at high speed is even harder. The human body, as it turns out, is quite squishy, and sudden acceleration is very dangerous for it. So the fastest human crewed spacecraft so far is Apollo 10, which reached almost 25,000 miles per hour on its return from the moon. That's about 17 times slower than the Parker Solar Probe. And at that speed, it would still take more than 100,000 years just to reach Proxima Centauri, the closest star to the sun. Furthermore, the energy required to accelerate spacecraft to higher speeds, and if needed to decelerate them so that they can arrive safely, represents a great challenge. And to make matters worse, there's also numerous hazards in space, including ionizing radiation, the deteriorating effects of long-term weightlessness on the human body, and the dangers of micrometeoroids and space debris, not to mention potential mental health issues from long-term being kind of like stuck in a box. And these are all challenges that have yet to be overcome. Still, there have been a few means of travel studied for the distant future. Unfortunately for most sci-fi fans out there, faster than light travel is physically impossible. But a sci-fi concept that might be more feasible is the ramjet engine, shown at left, which would use very large electromagnetic fields to scoop up hydrogen from the interstellar medium, the space between stars. At high speeds, that scooped up hydrogen mass would be compressed in a constricted magnetic field until thermonuclear fusion occurred, with the magnetic field directing the energy away from the ship, accelerating the ship forward. The feasibility of this type of ship is dependent on the amount of hydrogen in the interstellar medium, which may or may not be dense enough for this to work. Another interstellar ship concept, Project Orion, is shown at left here, was studied in the 1950s to use nuclear pulse propulsion, with nuclear explosions providing continuous thrust. Such a vehicle taking off from Earth would be a horrible idea. It would leave significant nuclear fallout, so it would have to be launched from space. Still, there's an international partial nuclear test ban treaty, which banned nuclear explosions in space, and Project Orion was eventually abandoned. Project Daedalus, shown at right, was an engineering design study for an uncrewed interstellar ship carried out in the 1970s by the British Interplanetary Society. The concept here was to design a fusion rocket capable of reaching Barnard's star, which is about 6 light years away, within a human lifetime. And this project was sort of inspired by Project Orion. And so it would use nuclear fusion with smaller bursts with the design capable of reaching 12% of the speed of light. This project wasn't actually intended to be built, but just to kind of assert that interstellar travel within human lifetimes could be feasible. Another concept is the use of light sails, for example, in Project Dragonfly, which hopes to send a small uncrewed probe propelled by a laser sail capable of reaching Alpha Centauri within 100 years. The laser beam would be set up somewhere in the solar system and then aimed at a thin reflective surface, the sail, on the spacecraft. Pictured at left is an artist's concept of a swarm of such tiny laser sail probes. Similar designs, such as solar sails, use the energy imparted onto large mirrors by sunlight as a method of propulsion. Solar sails have very low thrust propulsion, but they require no fuel, and since the propulsion would be constant, they might actually be feasible for interstellar travel. Japan actually launched Icaros, shown here on the right, which is the first space probe to use a solar sail in 2010. And this demonstrated that solar sails are actually effective, at least for travel within our solar system. Okay. So the last thing I want to talk about is what we would do once we got to these worlds, assuming we figure out how to get there. Because even if some worlds might be habitable in the sense that they can support liquid water, that doesn't mean that they have the conditions where humans can survive. And this is where terraforming comes in. Terraforming is the concept of modifying the conditions of another world to match the conditions on Earth, to allow humans to survive on the new planet. Shown here are artist concepts of terraforming Mars and Venus. And we don't have the technology yet, but we have a basic idea of how terraforming would work. It would be a gradual process. You'd start by importing necessary gases to the atmosphere. Some have suggested placing mirrors in orbit around worlds with thin atmospheres to help cause a greenhouse effect to thicken the atmosphere. You could also change the planet's surface to affect its albedo or its reflectivity, and making a world less reflected would also help it retain more heat. The implantation of microbial life from Earth, and eventually plant life, could help build an Earth-like atmosphere by effectively following the history of life's evolution on Earth. Plant life could accelerate the production of oxygen in the atmosphere, which could eventually make the world capable of housing animal life, including humans. As you can imagine, completely changing the atmosphere and surface of another planet would be extremely resource intensive. But terraforming is studied and discussed extensively because it would likely be necessary if we wanted to create an environment where humans could survive freely on the surface of other worlds, rather than just inside sort of like closed bases, like the artist concepts shown here. However, there are some moral quandaries regarding whether terraforming should be done, even if it is possible, especially if the world in question already contains life. Now, some argue that if the life we're displacing is very simple, like microbes, there's little ethically wrong. Some, like aerospace engineer Robert Zubrin, go further to say that humans have a right as the first spacefaring creatures in our solar system to, and I quote, make that land grab. And here again, our history lesson is relevant. The attitude is clearly tied to manifest destiny in the European Age of Discovery. This idea that if land is out there, we ought to take it, that it's ours to grab, is a blatantly colonial mentality. Of course, grabbing land on an uninhabited world, or one inhabited only by simple microbes, is not as troublesome as historical land grabs in America, where whites stole indigenous land and committed genocide in the process. Still, resource grabs without genocide have happened before too. And just because living beings aren't being massacred doesn't mean that they won't be exploited and harmed, and the environment irreparably damaged for the sake of profit. On the other hand, there are also those who argue that humankind is too vulnerable on Earth, and expanding to other worlds is necessary to ensure our long-term survival. And it's certainly true that our time on Earth is limited, if not from human-made disasters or the various dangers in space. At least as our sun continues to age, the Earth will eventually become so hot that its water will evaporate within about 1 billion years. But the assumption that colonizing other planets will automatically protect us fails to answer questions integral to the lives of both the colonizers and whoever remains on Earth. Firstly, who will be selected to colonize these other worlds, and who will stay behind? Remember that space travel is dangerous and expensive, and even in the distant future, it's very doubtful that we could simply move the entire human population, billions of people, off of Earth. So then we have to ask, will the resources used for colonization come at the expense of humans who remain on Earth? Will the work be dangerous? Will people be exploited in the process? And assuming we solve all of these problems and successfully terraform and settle another world, how will we protect it from falling victim to the same injustices that historically plague human society? Do we really want to model these future civilizations on colonizing, given the exploitative, genocidal, and destructive history of colonization on Earth? And it's not just human injustice we have to worry about, it's also environmental justice. And we know this because a sort of anti-terraforming is happening around us today, here, now. The Earth is becoming less habitable due to human technology as our actions increase the carbon dioxide and methane in the atmosphere. Terraforming. As shown in the image here, the Earth's atmosphere has changed significantly over its lengthy history, but the rate of change we're experiencing now is completely unprecedented. Despite the lies spread by some politicians, the scientific community is in absolute consensus that humans are the cause. And this may seem like another reason to try to escape Earth, but if we don't learn from our problems here first, we're likely to repeat them. Any future worlds that we inhabit could suffer the same climate calamity we've created for ourselves on Earth. Just like the lengthy history of colonization on Earth, land grabs in space will be driven by profit rather than the preservation and protection of human life and the environment. Even if humans as a species are in more danger of dying from a single great extinction event if we all live on one planet, there's no reason to think human civilizations on other worlds would be intrinsically safer, or that such expansion would do anything other than provide a new means to exploit both human lives and the environment for profit. And this isn't to say that we absolutely shouldn't pursue terraforming technologies. After all, climate engineering techniques can actually help us combat climate change on Earth. Nor is it to say that space exploration should be avoided. Rather, this is a reminder that exploration and scientific advancement often come at the cost of human life. Once again, we have to acknowledge our history and learn from it. Looking for a home among the stars won't save us until we change how we interact with each other and with our environment in order to put basic rights above profit. And maybe it's a matter of perspective, but where better to get perspective than from Voyager 1's pale blue dot? In this image, we see the Earth as it is, an extraordinary, beautiful world floating in space. When you look at the night sky, and when you imagine these distant worlds, and when you marvel at the expanse and vastness and beauty of the universe, remember this pale blue dot. Remember that Earth is among the stars, too. I've listed some resources here for further reading. All of this information is in the description of this video. Thank you for your time.
Thanks, John. That was really great. And also my brain is this buzz of screaming internally and also shouting out political manifestos because Yeah, we don't want to replicate what we've done here out there.
Right. A
Yep.
lot to digest, a lot to think about as we sort of figure out where our place is in the universe, you know?
Yeah.
So we got a couple of questions. First of all, from Josh Willis.
Yeah.
Is there Trappist beer on any of the Trappist planets? So Trappist beer being beer from the Trappist monks.
Is any of the, wait, sorry. So the question is, any of the Trappist beer from the Trappist monks from the Trappist planets?
Yeah.
That's a great question. The reverse is true. The Trappist planets are named after the Trappist beer and monks. Fun fact, the Trappist, for anyone who doesn't know, there's a solar system called Trappist, where there are, I believe, 7, if I recall correctly, exoplanets that are plausibly within the habitable zone. Whether or not they're actually habitable is a little bit more debatable, and I think we're leaning towards very not likely based on the properties of the star. There's some severe flaring that goes on there. Yeah.
All right, another question, and this one has an answer. So if you want to comment on both of them, so the question is from Jessica O'Brien, and it is, why is traveling at the speed of light physically impossible? From Mike Russo, an answer that he says is the bad answer is that the stuff, aka atoms, is held together by photons, but they move at the speed of light. So if you move at the speed of light, you stop being stuck together.
So that's probably actually a better answer than I could give. I will note that Mike Russo is a physicist and I am an astronomer. And while I studied physics in my undergrad, my understanding of physics is probably not better than his. Right. So the way I also like to think of it, kind of like that, maybe trying to word it slightly differently if I could, would be to say, the only things that can go at the speed of light are things that are massless. You need to be massless. You need to be a photon or something like that, we think, in order to go at the speed of light. By nature of our existence, or anything that we try to send physically, like a probe or a spaceship or anything like that, it will have mass, and it won't, we can kind of like asymptotically approach the speed of light, but we'll never quite get there.
And we got one last question from Josh Willis. Could we do a multi-generational mission to Alpha Centauri?
Absolutely. And this is another thing that I didn't touch on that does come up a lot in interstellar travel ideas, is these multi-generational missions where you effectively have a big spaceship crewed with many families of people. And okay, the first families of people who are on the spaceship don't make it to the end game. And a few generations down the line, they hope that some people are still alive on that spaceship when the spaceship arrives. And this is, it's a plausible thing. I think the studies to make sure that you do it in a safe and healthy way for the people you're sending are the types of studies that we have not remotely approached to doing yet. I think another thing you have to watch out for is with sort of like the exponential increase in technological capabilities. Another thing I didn't get into is that with space missions and like sending things really far away, a number that gets kind of tossed about is 50 years. If you can't make it to your destination in about 50 years, you probably shouldn't go, because the expectation is within 50 years, you'll be able to send a spaceship to go to that destination faster, to the point that it will be able to catch up and pass the original spaceship that you already sent. And you would really hate to be on that spaceship that's like, I'm on the first mission to Alpha Centauri, and it's going to take you 300 years to get there. And then 50 years later, someone else launches a spacecraft that takes 50 years to get there. And they're already there 200 years before you show up.
That reminds me of when I was touring mission control at Houston once, and my dreams of being an astronaut properly died when they said that for the Mars mission, it's basically 2 years in a minivan with 3 other people.
Yeah.
No thanks.
Not healthy, probably.
Oh, well.
I don't think we have any more questions. So thank you so much, MC.
Thank you.
And so who do we have next, MCM33?
Well, you know him, you love him, you've already heard him speak. Allow me to reintroduce the Cosmic Kid, bringing us What's Up?
What's up? pull that up. All right, what's up, everybody? Welcome to the September edition of What's Up, the monthly show where I tell you what's up in the sky that you can observe. So first of all, I've got the target of the month, a really special thing that's coming up, and that's going to be Mars. So you're going to hear a lot about Mars in a couple of minutes. But what's really great about Mars is that it's the perfect time to look at Mars if you have a telescope or a pair of binoculars. Around this time of year, it's up right around after 10 o'clock at night. So it's not too late at night. It's pretty reasonable for you to go up and look at it. It's actually entering opposition on October 13th, which is when it's going to be the closest to Earth that it ever is for several years. So it's going to be really big and bright in the sky and easy to look at. And one interesting thing about Mars, looking at it right now, is that it just recently had its solstice, which means that its tilt is pointing at the sun at sort of the most that it will point at, which means that the southern ice cap is looking almost directly at us. And you can actually observe the southern ice cap. It's a little small right now because it's summer in the south of Mars, but it's still a fairly bright white spot that you should be able to see with a decent telescope, as long as you go out to a good dark site. But Mars is going to be a wonderful, wonderful target to look at over the next month. Now, of course, we have the other planets as well, who are also great targets to look at, and I guess they're cool. Venus is going to be really bright up in the pre-dawn sky. Jupiter and Saturn are going to be up most of the night, and they're really close together, so it's a really nice observing opportunity. It makes for great pictures. And if you're up tomorrow night, right around 9:15, you can actually see the great red spot, because right around 9:15, it'll be transiting Jupiter's meridian and sort of be right in the middle of Jupiter as it's facing us. So it'll be the perfect time to go look at Jupiter, look at the red spot, look at Jupiter's moons. And it's a new moon, so you're not going to have any moonlight bothering you or anything. It'll be a nice dark night to go look at Jupiter. And so the last thing I want to talk about for what's up is, well, the times, they are changing. You're coming up on the September equinox, which is the autumnal equinox if you're in the northern hemisphere. This marks the end of summer and the beginning of autumn. This happens because the sun crosses the celestial equator and appears to be moving lower across the sky. And so Earth will be equally lit by the sun on each side. It's often used in cultures as a celebration of harvest, especially based on the knowledge of ancient astronomers. For instance, there's a Slavic harvest festival called Dozinski. There's a Korean harvest festival called Chuseok, and a Persian harvest festival called Meragan, which all take place during the autumnal equinox. So it's a really nice time, and there's a lot of history involved with a lot of harvest festivals and feast festivals right around the equinox. And that, my friends, is what's up.
Thank you, Cosmic Kid. And also, I completely forgot to ask. This is Astronomy on Tap. So what are you drinking?
I am drinking some gin and tonics. It's been my new drink of choice lately.
That is a good choice.
It's wonderful. You know, it makes you drunk, but it also hydrates you at the same time.
I wonder if there's like a curve.
Well,
Don't worry about it.
We're scientists. We can experiment and figure it out. I just need a couple more gin and tonics.
I'm going for something a little lighter myself. It is the Backyard Bee from Revolver Brewing. And I just remembered that the first beer I had of theirs was called Redshift. And I've never been able to find it again. And it's very distressing as an astronomer.
Well, you gotta find it and give it as gift to all your high redshift cosmologists.
Do I know any?
You know a couple. I don't know if you like them.
Oh, moving on. Next up, we have Dark Matter Dude.
Hello.
Dark Matter Dude.
Oh,
It's a little dark. We're just gonna roll with this.
You're living up to your stage name?
Yep. That's what's going on. This was intentional. Okay. Hello everybody. So this is in the news for Astronomy on Tap. And we're going to talk about some of the headlines that you may have seen in the news the past month or so. So to start us off, okay, this Venus thing that you may have seen before. So some astronomers have been kind of one of like the pinnacles for planetary astronomy has been trying to find evidence that may support life. And so one of the ways to do that is to look for things that we think would be signatures of life. So one of these is called phosphine, or pH3. On Earth, we know it mainly. Its sources are kind of like an industrial processing, or via a whole bunch of microbes. There are microbes in your stomach that are making phosphine right now. Not a lot, not enough to kill you, but it's there. And the reason that's a really good biomarker, it kind of has the same logic as oxygen. So we know so on Earth, at least, it's made by life, and it's pretty unstable. It likes to, like natural O2 gas likes to react with things and become something else. pH3 is very similar. So if there's a lot of it, that means that there's something replenishing it, probably life. So these astronomers, what they did was they took some of our best infrared telescopes and pointed them at Venus. Took spectroscopy to figure out whether or not there was any observational signatures of phosphine in the atmosphere, and they found phosphine. So the idea is that there's a lot of phosphine. There's more than you would reasonably expect from any sort of physical explanation that we can think of at this time. So they had this whole model where they incorporated things like sunlight, lightning, meteors, volcanic activity, which we know happens on Venus. And at least to the extent that we can model it, there isn't a good explanation for why there's so much phosphine in Venus's atmosphere. And so the next thing is, well, what if there's life? So the thing then is, so we've ruled out things that we know about on Venus that could do this, but there's probably a lot of stuff on Venus that we don't know about. And some unknown chemistry, some unknown geology could also be producing this phosphine. So for now, and there's a good example of this. So this is like the chemical reactions that they include in their models to get to phosphine all the way on the right over there. This pH3. All the solid lines are the reactions that we know, and the dotted lines are the things that we think happen. And so even in the stuff that we know, we don't know, there's a lot of uncertainty. And there's also stuff that we have no idea what's out there. We have no idea what's going on Venus. And so grain of salt, there's this really cool phosphine signature from Venus that might be a biosignature. So that's really neat. So that's the Venus thing. We're getting that out of the way, because last time when I did a really big piece of news, I put it at the end and everyone was asking, aren't you going to do this story? Well, here it is. Here it is at the front. We're going to move on now. So we also got a really another cool LIGO signal. So LIGO and Virgo are gravitational wave detectors. So when two massive things, typically black holes, are orbiting around each other and eventually merge and combine into one massive black hole, that merger creates a gravitational disturbance or a gravitational wave that shoots through the universe, and we can detect with these ultra sensitive lasers that LIGO is built out of. And so they found a merger, and the really interesting thing are the masses of these things. First off, it's the most massive merger that we've seen from LIGO so far. It was an 85 solar masses plus 66 solar masses made 142 solar mass black hole. So those are really big numbers. They're a lot bigger than all the other LIGO black holes that we see in that diagram on the right. Now, there's a lot of really cool things. The big headlines. There's 7 solar masses, right? That, like, if you take 85 and that plus 66, the numbers don't quite add up just because of the numbers that I chose. But essentially, like, 7 solar masses disappeared, like it's gone. That's the energy that got radiated into this gravitational wave, And that happened in like a fraction of a second, which is utterly astonishing. Another cool thing is the resulting black hole, the 142 solar masses, puts it in a very interesting mass range. Up until now, we've observed things that are a lot smaller than that. So like your kind of stellar mass black holes are what they're called. And then you have these supermassive black holes that are at the center of galaxies that are like 10 to the 8 to even larger solar masses. But there's a gap there where we haven't actually really observed a lot of stuff going on there. There are some candidates, but this is the first time that we've actually really detected what's called an intermediate mass black hole. And that in itself is really astonishing. We think they should exist, but we hadn't found one until now, and now we have. That's cool. Finally, there's this really interesting thing where just because of the physics of how one of the main channels for how black holes form, it's very hard to get a black hole that's more massive than about 65 solar masses. So the one that's 66 is fine. That's within our measurement errors. But the 85 solar mass one is definitely above that range. And so the fact that it exists and was able to experience a merger with something else is kind of hard to explain. That either means that 85 solar mass black holes happen naturally, which would be really weird, or that it had already experienced a merger and then got caught up with another black hole and merged again. And that's also really hard to do. It's very hard to experience, like to make a merger happen and then have it get captured by something else. So that's challenging our models from like a wide variety of ideas. Okay, so now we have this dark matter misbehaving thing. I didn't say this. I've been drinking White Claw and it's hitting my body right now. So bear with me. So there's this idea of dark matter misbehaving. So one of the ways that we've observed dark matter, that we measure the masses of galaxies and galaxy clusters, is by this idea of that mass bends light. So gravitational lensing. It's very similar to, if any of you have a wine glass right now, because you're at home, if you take your wine glass and put it over some like text or print or paper, and try to look through like the rim of the glass and how it gets distorted and circular, same idea, but with mass. Bending the light going around it. So that type of gravitational lensing is usually there's a galaxy way far away and then a galaxy cluster in between us, and the mass from the cluster bends the very distant galaxy light, and you get these arcs. You might be able to see them in this image here. There's arc here, arc, these arcs that are around this galaxy cluster. So the interesting thing is that what these people did was they took measurements and observed lensing around the clusters. That's not new. It agreed with what's been done before. But they were actually able to observe, in addition, lensing that was done by single galaxies that were in the cluster itself. So that's these zoom-ins over here, where there's a particular galaxy that's in the cluster, and then there's arcs or distortions or bumps that are around those individual galaxies. Now, what's interesting, two bits about this. If you look at simulations to see how often this should happen, observationally, we're seeing it happen about 10 times as often as we kind of think it should, based on how we've simulated the universe. That's weird. Secondly, if you look at the motions of stars in the galaxies, in the individual galaxies that are in the cluster, the mass that you measure, the dark matter that you measure from those motions, is very concentrated relative to what you'd expect from simulations. So there's a lot of weird stuff going on here. It's possible that this concentration is due to the galaxies, like the stars in the galaxy kind of interacting with the dark matter that's around it. That's possible. But yeah, we're still figuring out what dark matter is, and this is another way that it's kind of surprising us and we don't quite know what's going on. Now, very similar gravitational lensing story, but now we're talking about observing things at the very far edge of the universe. So when galaxy lensing is perfect, you actually can get a ring that's encompasses the mass that you're measuring around it. So like a little point source very far away, a little galaxy very far away that should be a dot. If you line things up with a galaxy that's in the middle just right, you get a perfect ring. So this isn't new. This is been known for a while. But the interesting thing is that you can take that image and then reconstruct what the original source light is that's very, very far away. And what's weird is that it looks like a normal, disky, Milky Way-like galaxy, except way out at the edge of the universe. About this thing looks like it does right now. This very normal-looking Milky Way-type galaxy, disky, only 1.5 billion years since the universe formed. So that's weird already. But the real problem with this is that it looks like a perfectly normal disk, but it's forming stars at 350 solar masses per year. Now, for context, the Milky Way right now, the Milky Way that we live in, forms about 1 to 2 solar masses per year. So this is several hundred times the star formation. And star formation isn't a very peaceful process. It's very bursty. Like if there's all the star formation happening, you'd expect it to be ejecting out gas and providing a whole bunch of feedback. It would basically look like a mess. But the fact that it looks like such a normal, disky object is really weird. And we don't know what's going on, friends, but we're going to figure it out. Okay, finally, public service announcement. Okay. When you see a headline, we're all learning together right here. Okay, when you see a headline that says something like, "Oh, great, NASA says an asteroid is headed our way right before Election Day," which is a real headline that happened in August. Okay, y'all, it's clickbait. It is. It just is. So this particular asteroid, it's actually funny. It's called 2018 VP1. The VP bit is the funny bit because vice president, and then it's coming our way like literally like 1 or 2 days before Election Day. But this asteroid, you really don't have to worry about. It's only 2 meters across. If it hits us, which it probably won't, it's only got like a 0.4% chance of hitting us. If it does, it's going to burn up in the atmosphere just fine. No problems at all. The other one, there were two headlines this past month that were like this. And so this one happened September 1st. An airplane-sized asteroid gives Earth a close shave. So same idea here. This asteroid's much bigger. It's 20 to 50 meters, which is actually really big. If it hit us, it's about the same size as an asteroid that hit Russia in 2013, which produced basically it was the equivalent of 500,000 tons of TNT, which was enough to like shatter windows and like flatten parts of a town. Like it was bad. But this asteroid literally basically had 0% chance of hitting us. And it didn't, obviously, because it's mid-September now and you haven't heard about this, about a big asteroid hitting us and doing a lot of damage. What's great is that now, because it came very close to us, it was at the best time to kind of figure out what its orbit is. And so now we know a lot more about the orbit, and we can do a better job of predicting when it will come next, because this one's like in a particular ratio with how Earth is orbiting around the sun. So it'll come back eventually. So now we have a lot more information, and we can do a lot better about constraining what the orbit is and whether or not it'll hit us. But yes, both of these headlines were very clickbaity. I was not happy when I saw these. Yeah, that's it. if an asteroid's gonna hit us, you'll know. All the astronomers will sound the alarms, but this wasn't it. That's it. That's what was in the news.
Right. Thanks, Dark Matter Dude. It has gotten darker where you are, I see.
I don't see any questions in the chat, so thank you very much. Yeah.
Right.
Next up, we've got the Carbon Queen, so come on up.
For the
Talking
record,
about Mars exploration.
For the record, Carbon Queen, aka Taylor, is a high redshift astronomer who I would buy a beer for. Though
Thank you.
aren't we all working at low redshift since we live at a redshift of 0?
True.
Oh, right. And a fun fact about Taylor is that she has 2 cats on whom she is playing a very long-running prank by slowly filling their apartment with plants.
Is that a prank on them, or is that just making you happy?
It's a win-win situation.
Win-win situation. That's totally fair. So Taylor, what are you drinking tonight?
I am drinking a concoction I threw together of like coconut milk and rum and some pineapple. But the important part is it's in a Borg ship. So I just want y'all to know I'm drinking out of a Borg ship tonight. So.
It is lovely.
Wonderfully geeky. I love it.
Thank you. I try.
All right, take it away, Carbon Queen.
All right. Let me share my screen. Okay, everyone can see this, I'm assuming. All right, so today, as it's been kind of alluded to this whole time, I'm going to be talking about our future on Mars. And another way you could think of this is, a history of humans really wanting to be on Mars instead of Earth. All right, so before we really get started, I warned a few people, but there will be a drinking game involved with this talk. So take your drink, be it water, wine, bathtub moonshine, coffee, tea, beer, whatever. Take your drink and take a drink of your drink whenever you see this NASA image of Mars. So anytime you see it, I need you to take a drink of your drink. And tonight, right now, this one starts. So cheers. All right, drink responsibly. I put it in here a lot, so I'm not gonna point out whenever it comes by. You just have to keep track. All right, so Mars, as we're at least somewhat familiar with, is this beautiful red planet in our solar system, and it's often been inspired, for a century now and more, science fiction writers to talk about it. Here's just a handful of some of the movies that have come out of Mars, talking about Mars, be it using Mars as a backdrop or actually featuring Mars in the center of the story. There's also plenty, stories, written, TV shows, all of that. A particular show I kind of want to highlight just because it's cool is this one called Mars, which is a 2016 TV show run by National Geographic. And just the thing I thought was cool about this show is it's at every episode, half of the episode is like this 2030s, 2040s sci-fi drama. And then the other half is the year 2016 when it was filmed interviewing scientists and engineers about space travel. So check it out. It's actually really cool and pretty accurate. So first, before we get started with talking about travel to Mars, let's just get to know our red neighbor a little bit. So this is a really very much not to scale solar system of the model showing the innermost 5 planets I made. All of these images, fun fact, are NASA images of these planets. And then this is a 10-year time lapse of the sun. But as you can see, as we kind of already know, Mars is the 4th planet from the sun. It's this little red planet, a little bit smaller than Earth and Venus. And just for some fun facts about Mars, aside from its being the 4th planet, it's about half the size of Earth. By mass, it's about 10% the mass of the Earth. A Martian year on going around, for instance, taking a particular snapshot location of Mars and then waiting until it goes all the way around the sun and back to where it is in that snapshot is about 687 Earth days, which is about almost double of what an Earth year is, which is 365 Earth days. There are actually 2 moons around Mars, both of them significantly smaller than our moon, which is about the quarter size of the Earth. And then the atmosphere is about 10 times or 100 times thinner than the Earth's atmosphere. And this has lots of implications for future settlement of Mars, which I'll talk about later in this talk. It also has a tilt, kind of like what Yasin was the Cosmic Kid was pointing out in his talk earlier. Because of the tilt, Mars is actually very similar tilt to Earth, and so it actually has seasons like Earth does, spring, summer, autumn, and winter. However, because it's further away from the sun and its year is longer, all of those seasons are also longer. Because of its smaller mass, the the gravity on Mars is about 1/3 that of the gravity on Earth. And so this doesn't mean that, in those John Carter movies and stuff, that you jump 300 feet in the air. This means you're probably more likely, ignoring all other factors, if you were to jump a meter on Earth, you probably would jump 3 meters on Mars. And then also, as we kind of point out, Mars is this beautiful red planet. And why is it red? It's because it has this iron oxide or kind of rust in the soil. And when there's winds, which there often are on Mars, it also lifts the iron dust out of the soil and puts it in the atmosphere too. And that's why it just looks so red all the time. All right, so to talk about this exploration of Mars, we're going to focus on 3 particular subpoints. So we're first going to talk about traveling to Mars, both crewed and not crewed. And then we'll talk about the exploration of Mars, both crewed and not crewed. And then we'll talk about the settlement of Mars. So starting with traveling to Mars, if you were to have infinite money, which some people do, if you were to infinite money and you're sitting on the Earth and you're like, hey, I want to go to Mars like right now. You build this amazing, massive spaceship that could like zoom over there really quickly, like 2 months travel or something. And you get up into space and you wait till Mars gets right next to Earth, and then you zoom over really fast. You might think like that's the normal way to travel to Mars. That's actually really not practical for many reasons. John actually gave a really great description of traveling vast distances in space and what works and what doesn't. But just to kind of point out why this is not a good idea. First of all, that would require a ton of fuel. Ignoring all the other things, that would require a ton of fuel just to zoom that fast. Ignoring all the fuel that would be required to get this massive thing off of the ground on Earth and into orbit. And so that's just inefficient in many ways. Also, because if you were hoping to have multiple trips to Mars, doing that quickly with that much fuel is just, that's not sustainable. You can't do that more than once. And it's also, let's point out that it's bad for human life. So anything organic going at those fast speeds, kind of like what John pointed out, is really not healthy for your organs. It could kill you if you go too fast with all the accelerated force pressing on you. So all of these reasons is why this is never something that we do. A better method, one that's often used by NASA when going between planets or other big bodies in space, is called the Raman transfer orbit. So the way that this works is you have these 2 circles, right? You have the Earth's orbit around the sun, the bigger circle, which is Mars's orbit around the sun. And so instead of doing this radially outward thing, what we're going to do instead is, as the Earth is going on its orbit, we time it precisely and we shoot off this little orange dot. We shoot off our little rocket off of the Earth, and it does this like elliptical path that you can see. It steadily gets closer to Mars until eventually, hopefully you can see me and this at the same time, or my face is covering it, but eventually it lines up perfectly to where our little space shuttle overlaps exactly with where Mars is at that point in time. Now notice I keep pointing out that this is like a really timing specific thing. The alignment has to be perfect. And so you still are doing it when they get to their closest pass, but when it leaves Earth until when it gets to Mars and intersects, like you need that to be perfect, because if you do it too early or too late, Mars isn't going to be where your space shuttle ends up. So this is kind of where the idea of launch windows came from. So if you remember all the launches that we just had in this past summer, including the Mars 2020 launch, it was really important with this timing window to make sure that you're going to be with this particular orbit trajectory, that you're going to intersect exactly where you're expecting to with the thing you're trying to get to. Some basic descriptions of why this is the most commonly used one is it requires a lot less fuel. The only fuel you really use on it is like the initial thrust to get it into that particular elliptical orbit once in space, and then a thrust at the end to kind of slow it down so it can enter Mars's orbit. It's also really efficient. This is something you can do over and over and over again. A good note though is this does take longer, right? Like, so that really fast version that would probably kill you would be really fast. But this one is healthier for human life and also takes longer. So it's about 7 to 9 months of travel to get over there for the most part. Here's a really good example of this. This is with the InSight rover that they sent over in 2018. So you see at the very bottom, we started in May of 2018, and now it's doing this really beautiful trajectory, and it's going to take a second. When it gets to the end of the green arc, that's where it will be intersecting with Mars, which is the green dot. And that'll be about 7 months later. Beautiful. All right, so I was saying crewed versus not crewed. So in case you're not familiar, the concept of saying manned, like a manned spacecraft, is outdated, and NASA's actually requested for many, many years that we say crewed instead, because there's not just people in space. So talking about crewed space shuttles and trips through space using crewed systems. So if you have people on a spaceship, there are things you have to consider. So you need space for movement. You need a workout space, which I'll get into why that's important in a second. You need food and water. You need life support, you need bathroom space, you need a first aid in case anything goes wrong. And there's just a ton of other things that you could probably think of that you would have to take into account when you're dealing with people. On the other hand, if it's just a robotic mission, like with all these rovers we've been sending to Mars, but there's different limitations, but for the most part, cut out everything that requires like supporting living things. You could be a very compact situation. There's no need for food or water. The temperature requirement could be different, right? Like it could be colder, maybe if the machinery can handle it. Life support's definitely not necessary. So there's different considerations you need to take into account versus like for people on board versus no living thing on board. So talking about weightlessness in space, the human body is meant to be on Earth. So whenever our bodies are acclimated to Earth gravity and Earth's climate and the air on Earth. And so when we change that, understandably, our body might not like that. And so weightlessness in space kind of has an impact. And so if you're in space for a very long time, a lot of things can happen to you. First of all, you can have balance problems, the visual disturbances, because your sensors are all kind of messed up because you're like, where's the gravity? You can have damage to your heart muscle. And the reason why this is because, on Earth, when we're standing, gravity's pulling on everything on our body, right? So your bottom half has more liquid pooling in it technically because gravity's pulling stuff down. Like your blood system, for instance, is pulling everything down. So your heart's purpose is to push everything around and make sure it circulates. So it works at the efficiency it needs to make that work on Earth. So when you get up into space, your heart is doing the same amount of work, but it's just mostly pulling liquid the opposite direction. It's kind of like if you laid on a bed, you hung your head over the edge, and like your head starts to like get puffy and red. It's because the blood's kind of like hanging out up there. That's what happens in space when you see pictures of astronauts. That's why their faces are puffy. You can also have bone loss. And so if you're not working out, like this is one of workout contraptions you can use. If you're not taking care of your body as much as you can, you might have muscles atrophying and bone density going down, which makes it more brittle. A lot of things here. It's a lot of things you have to consider. So one particular, NASA always looks into this, right? Every single space agency is constantly monitoring this and seeing how it changes human bodies. But one really awesome study that they did was with astronaut Scott Kelly. So Scott Kelly is an amazing person just in general. He's been up into space 4 times. But one of the times was that he also broke records because he was in space for 522 days in a row. If you want to read more about it, he has a website about this. But the cool part about this was he has a twin named Mark Kelly, who is the man with a mustache on the right image. And so Mark also works for NASA. And so Mark was down on the Earth working for NASA while Scott was in space working for NASA. And so when Scott got back, they compared the two just to see like what did space do to Scott's body over the 522 days he was in space. So first of all, he was taller than Mark because your vertebrae are kind of stretched out because nothing is pulling down on them like gravity. But there's also like obviously negative effects. So it was a really interesting study you should definitely look into if you're curious. So kind of talking about the resources, there are limited resources and limited space whenever you're doing this massive expedition, especially if we're thinking of like expeditions of people to a different planet. And so some things you have to have on board are, for instance, water. Water is like a life necessity for humans. It's very necessary, but it's also very heavy, which requires a lot of fuel to get this thing off the ground. And so you have to be really conservative with the amount of water that you have on a spaceship. You also can have different types of food, veggies, fish, and meat. They would store them and pack them like they've done for the ISS, International Space Station. You also have fruits, beverages. These are just the regular food things you would need, but they require storage space and things to keep them from going bad. You also would need space for trash. Trash would need to be compacted and stored because you can't, because with the ISS, for instance, they make trips 4 times a year to bring up water and other supplies, but you don't get that when you're traveling to another planet. So you need to have space to put everything away in. You also need space for your bio waste. And then additionally, you need space for sleeping. And you also need space for exercise because of all of those negative things I just talked about. And there's obviously more things too. Like there's a lot of things you have to consider when you're talking about a voyage to another planet. Also, if you're traveling to another planet, it was probably a good idea to send stuff ahead of time because you don't just need food to sustain you while you're traveling, you need food to sustain you when you get there, right? In a perfect world, you'd be able to immediately start planting crops and grow stuff, but that's actually not how that would work. And so ideally, NASA is always thinking about this, right? So what would happen is you send supplies ahead of time. So you'd send water ahead of time because that's very heavy and hard to transport. You'd also send food ahead of time. Now there's an important caveat. So with the food, on the ISS, this food can last, unopened from 18 months to 3 years. But if you're doing a trip to Mars, for instance, it's approximately 5 years between if you're sending supplies and then sending people. And so you need food to last for 5 years. And this is actually something they don't have the capability of doing right now. So this is something that NASA is actively looking into for future plans of like going to Mars, for instance. And then I mentioned crops at the bottom right, because you could, if you have the capability, you can have these in the closed environments. John was showing a really great picture of this in his talk, but where you're growing your own crops, which is a really sustainable way to also have food. Another thing that Tharni also mentioned is this long-term habitation and confinement. So the NASA and other space organizations have obviously looked into this, because if you're stuck in this tiny, what you say, like a minivan with 3 people, like that's a really small confined space. And if you're doing this for months, like for instance, the 9 months it might take to get to Mars, oh no. And then you get to Mars and you're living in this small confined space on the planet where you can't escape. Like you need to be able to figure out as many things as you can to make this as easy in a process as possible. And so NASA started this program back in 2010, I think, called HI-SEAS, which is the Hawaii Space Exploration Analog and Simulation. And so they essentially have an isolated location on Mauna Loa, which is a volcanic mountain in Hawaii. And it has really similar Mars-like features. And then the missions last anywhere from 4 months to a year. And the whole purpose of these missions is to study how to keep a confined crew happy and healthy. And this is with the mindset of traveling to Mars and living on Mars for an extended period of time. All right, so now that we're talking about traveling there, let's talk about exploration. So just to briefly mention some early missions to Mars's orbit, just because it was cool that these were in the 1960s. Oh, so in the top left is Mariner 4. Mariner 4 and Mariner 3, but RIP never made it. They were both meant to go study Mars, and the first flybys ever happening for Mars. And so Mariner 4, one actually successfully survived. So Mariner 4 took the first close-up images of another planet, which was Mars. You were able to see through these images the lunar type impact craters, and you're also able to see that some of the craters had frost on them, which was kind of amazing. Mariner 6 and 7 were next, both actually worked. So they were focused on, in 1969, doing this flyby and taking close-up images of the Martian equator and the South Polar region. And so they analyzed the atmosphere and also the surface. And then in 1971, we had the first orbiting spacecraft of Mars. This was Mariner 9. Mariner 8 was supposed to as well, but it didn't work. So Mariner 9, when it got there, was supposed to take like this 360 image of all of Mars, the whole surface, as detailed as possible with the then top-of-the-line instruments. But when it got there, there was this large dust storm that obscured the entire planet, because that happens a lot on Mars. And the storm lasted for a month, and so Mariner just had to like circle and wait. And then eventually when the dust storm died down, it took this massive mosaic of Mars. And this is where they saw the first volcanoes, which, by the way, Mars houses the largest volcano in the solar system. And then also found this really massive Grand Canyon in the planet as well. And also was able to image the 2 moons at the same time. So a lot of really amazing work happened prior to 2000. And there's also more, these are the 3 I wanted to highlight. Now, talking about where are we now and the things on this planet, on the Mars planet, I wanted to highlight this tweet by one of my friends. I just love it. I think it was in 2018 when InSight was launched, and she said, "Do you guys realize there's a planet in our solar system entirely inhabited by robots?" Which is just kind of an amazing thought. So these are all the NASA rovers, in no particular order. It's just the ones I thought of, like, I guess the order I thought of them in. But just to show you some of them. So there's Curiosity, InSight, which is technically not a rover because it's stationary, but it's digging into underneath the surface of Mars to try and understand a little bit more geology of the planet. And then you have Opportunity and Spirit, which were called geologist rovers, and they were dropped off on either end of Mars on these areas that looked like they might have interesting features that might have been made by water sometime in the past. And they were going to investigate them and see if they are actually evidence of water. And then Pathfinder and Sojourner. So Pathfinder was this lander, so it was stationary once it landed, but it was carrying Sojourner, which is named after the abolitionist Sojourner Truth. And it was the first 2 things on the planet back in 1996. And they had a year mission, and it was just some amazing images of the first images they ever saw of the planet's surface. And back in July, we had Perseverance launch from the Mars 2020 campaign. And so Perseverance is on its way there. It will, I think, get there sometime in early 2021, I think. But yeah. So these are some of the images from Opportunity, and then I'll show some from Spirit, just because they took some beautiful images of the different types of rocks and other features you can see on Mars. So this is part of a panorama, and this is another planet, y'all. This is amazing. So this is some of the pictures. Here's, I love this one because you can see the tracks of Opportunity as I was driving around. These are cool because it was really important to study the rocks in different locations because, I mean, as you might expect, the composition, the way they look, the chemical makeup. It can tell you a lot about how they were formed and what was like happening in the past of this particular location on Mars. So for instance, these pebbles you see on the right, top right, those are generally only formed when water is involved. And so that was a really cool indication that there was probably water in this area at some point in the past. This is just a beautiful image of the surface and how orange it is. And here's some spirit photos. This is actually just kind of stunning to me. First of all, the citation mentioned Texas A&M. But this is showing a sunset on Mars. And so the sun also will look smaller on Mars because it's further away from the sun, but this is just a stunning image. And here are just some more images. On the bottom, you can see this is from Spirit. And so Spirit saw some dust devils happening because it's incredibly dusty and windy on Mars. All right, so now talking about exploration with people. So the first crewed missions, this is one of the concepts drawn up by NASA. So the idea would be you have this really small settlement. The thing on the right is probably housing either storage or maybe their food source that they're growing. You have a little rover here and some people. So this is kind of how the basic setup would look for a crewed mission, probably less than a dozen people. Now, the important things you need to keep in mind for a crewed mission are habitation. So you due to Mars's thin atmosphere, you'd need some kind of enclosed living area. Generally, as humans, we can survive with just oxygen, but that's not the best, right? Like our atmosphere is mostly oxygen, nitrogen, and a few others. So ideally, the air in a habitat would be oxygen and nitrogen. And you can actually get nitrogen from the Mars atmosphere, but unfortunately, it's really connected with argon in the atmosphere. So an air and habitat on Mars would probably be a combination of argon, nitrogen, and oxygen. Also, when it comes to growing food on Mars, like I was mentioning before, this would reduce the amount of food that is being shipped over, which saves on weight, saves on fuel, and also is just much more sustainable to try and grow your own food. As you might expect, of course, if they're there, there's going to be detailed exploration happening constantly. So expeditions would always occur. This would mean that not only would you need your habitation space, including all the other things I talked about when it came to like the ship traveling over, you need all those on the planet as well. You also need space for your science and all the science, like the collecting of little samples and also all the science equipment that's necessary. And then finally, just as an important note, while NASA and other space agencies work their best to prepare for everything, any possible thing they can imagine, this is why the rovers are so helpful, not only to understand Mars, but also to think ahead and think what are the dangers that people could face if they go there. There are things that, of course, you can't predict. And so having as much preparation as possible on how to handle these unpredictable situations is really critical. And of course, they are thinking about this. As far as natural resources on Mars and capitalism and all that fun stuff, John gave a really great talk earlier. So if you missed that, go back, rewind, and listen to it because he covers all that better than I did. So now the final section, we're going to talk about settlement for a few minutes. So just kind of highlighting again, crewed missions with like less than a dozen people, this is probably what the setup would look like. But if you're trying to talk about settlement of a lot of people, this is more of what the situation might look like. So you'll have this massive dome where a lot of people are housed, including all the other things you need, like recreational space, living quarters, things like that. And then a massive area to grow a lot of food because you need to feed that population. And then all the other things like water processing plants and stuff. This is actually from Mars 1, which got bankrupt recently. So that might not happen. But this is a NASA concept, which is actually, I think, more accurate, as you might expect, because it's NASA. So this is an underground system. But essentially for an actual settlement, which by the way, we usually avoid trying to say colony, mostly because of all the amazing, awful things that John talked about in his talk and why that like the implications of saying colony and colonizing and stuff, that's why we avoid saying that. So say settle or settlement when you talk about going to another planet. So some of the things that you might need as far as equipment is concerned are, basic utilities, habitats for living, storage, workspaces, airlocks for people who go out onto the surface and come back in, resource extraction equipment. The list goes on, right? But one of the most important ones is off-planet communication, like the ability to talk to Earth in case things go wrong. That's important. All right, so some considerations for people on Mars. I was mentioning before, Mars's thin atmosphere has an effect. And so radiation, because Mars has a thin atmosphere and it doesn't have a magnetosphere like Earth does, you would be subject to more damaging radiation on Mars. And so what this means is to be properly safe for people living on Mars, you would want either, if you're living in the dome thing I was showing you before, either have the walls be like a foot thick of steel or live underground as another alternative that's viable. Some physical effects would affect you on Mars, similar to weightlessness in space. The gravity is less on Mars than it is on the Earth. And so because of the difference in gravity, you still have the chances of having some amount of bone mass loss, some amount of muscle mass loss, and circulation issues, and all of those other things. And there's also the psychological impact, kind of like what we talked about, where you're stuck in this tiny box with a lot of friends. Terraforming is also something that John talked about, which is great. So I'm going to just cover some basic notes here. But essentially, the terraforming idea, the greenhouse gases and making atmosphere thicker, and then adding vegetation possibly, very time intensive, as you might imagine. Even if we had some, non-existent but theoretical amazing technology to help us do this, it would probably be a process of 100 years or more. And so this is like a lengthy process. It'd also be very expensive, unlikely that a single government would fund this. And even in a global effort, unlikely that it would be funded. It's also very, very hard. So currently, as we've mentioned, we don't have the technology to do this. This is all still something that mostly is led by science fiction writers, but also talked about actively by scientists like people at NASA. We also, if you were to try and use just things on Mars to create the greenhouse gases to make the atmosphere thicker, there's actually not enough natural resources on Mars. If you were to take every single possible thing on Mars that could create greenhouse gases and use them all combined, it'd give you about 7% of what you need to match the Earth's atmosphere thickness. So you would need to provide additional sources, which would also be expensive, not only in shipping them over, but also probably creating those resources. NASA in 2018 gave a really great summary about the terraforming is not currently possible using present day technology. And then for all the ethical ramifications of terraforming, which I was going to talk about, but John did my job for me, which is great. Go back and look at John's talk. And just kind of as a final thought, what about life on Mars? So there obviously is evidence that there was liquid water in the past on Mars at some point, which means that those were hospitable past environments where microbial life might have lived. We have not found any evidence yet of actual microbial life, just evidence of like a good environment for it. So as of right now, we don't think there's life on Mars, but granted, we'll find out. Of course, we have all these rovers running around, and one day we might have people running around. But an important note, which is kind of an unfortunate one, even though everything that gets put into space, be it a space telescope, a satellite, or these rovers that go to another planet, they are built in these clean rooms where there's barely any spores, as few things as possible that could contaminate. But even with those extra precautions and how careful everyone is when they create these things, there are likely some amount of microbes that go onto these rovers, for instance, and are on these other planets. And so there is a possibility, as pristine as we made everything, there's a possibility that there's Earth microbial life someplace on Mars. Don't quote me on that, but that is an unfortunate possibility. But yeah, so I'll take any questions now, and those are just a number more Marses for you to take some drinks. And thank you guys.
Thank you so much, Carbon Queen. Wonderful talk.
I'm almost through my beer thanks to that drinking game.
Yes, my goal.
I ran out of my drink the first slide, so that was fun. We got a couple of questions in the chat. So first of all, from Curtis Hunt, why is Mars so orange? aka, why is there so much iron oxide on Mars?
Oh, that's a great question. I've always just assumed that's the chemical makeup of Mars, and so that's what's there. And so that's why you would have that component. I've actually never really thought through the before question that he just asked of what really created all this iron oxide. So that's a really good question. I don't have a good answer for you. You could Google, but yeah.
The next one comes from Sylvie. I swear it was right here. Yes, Sylvie. How do we handle waste in space?
That's a great question. Okay, so I wanted to include slides, but I was just so worried I'd go over time, which I think I already did. But it's really cool. So if we're talking about the ISS, which again, keep in mind, because I mentioned, the ISS has things that come up like resupplying that happens about 4 times a year. So ignoring that part, the way that they handle trash and waste. So the not human waste, like just the regular waste, is compacted. And so they heat and compact it. Think about like those 1970s trash cans where like you could literally turn on a heater and it just compacts it. So it was a thing. And so there's this really cool images you can find of they're just like massive discs and they're compacted trash. Like you can see like a Capri Sun logo on one of them. And it's like this heated and compacted disc. And the cool part is they're looking into, it's always good to try and reuse everything, right? So even with the trash, if there's some way to find that and make it useful, how amazing would that be for these travels to Mars, for instance? And so NASA and others are looking into what if you could use these disks as like shielding from radiation. So the trash that you're making, it literally helps provide reinforcement to protect you from radiation. That's what they're looking into there. As far as biowaste is concerned, on the space station, they have massive like jugs that will hold like the pee from people, and then they have like little bags, like sealable bags for like the solid waste from people, and then they just kind of put them away. And then, so, but again, like this obviously would build up, right? Like if people have bowel movements like once a day and they pee 3 times a day or something, I don't know what a normal human's amount is, but like imagine that, and then imagine how many people might be on a spaceship, like that storage space, that goes away really quickly. So.
We got a question from Joshua Willis. Are the rovers controlled remotely in real time or via AI?
Oh, that's a good question. I think it's a combination. Like they get directions, but they are a little autonomous in that way, but I'm actually not 100% sure. I don't know if y'all have any insight on that. Insights on the rovers.
So if I remember correctly, the light travel distance between Earth and Mars is around 14 minutes, on where Earth.
There's a 14-minute delay. Yeah.
So I believe they have some autonomous control in case something comes up in the 14 minutes between a command coming in and the robot committing it. But I also believe that they move so slow that humans have plenty of time to course correct.
I think that's it. Yeah, like there's definitely, because when I was reading about the different rovers, they were talking about directing them to look at certain things or do certain things. But there definitely must be some kind of like machine learning or autonomy that they have to be able to do basic functions on their own without human input.
Fair enough.
I'm trying to remember everything I read in The Martian, and nothing is coming to me. Yeah, would recommend The Martian. Oh.
Good book, good movie.
Right.
One last question real quick. Would Mars even be able to hold on to sufficient atmosphere if it could be created there?
That's a good question. I would assume yes, right? Based on the, yes, no, yeah, I would assume so. Because there's already an atmosphere there, and so you can just pile to it, and then there's gravity holding most things down, among other forces involved. And so I think the question here is because Mars has a really weak magnetic field, solar radiation strip away the atmosphere. So the question is, I guess, would it strip it away faster than we can hold on to it? I don't think so. But granted, you would have to, I guess it's probably a balance of how quickly can you build up the gases versus how quickly they could be destroyed.
Right.
I think it's possible, yes.
Okay, great. Well, that's all the questions we have. So thank you so much, Carbon Queen, for an excellent talk.
No problem.
All right. Now to our last event of the evening, trivia answers.
Woo!
I don't know who's pulling that up. Is it me?
Yeah, I can pull it up.
Thank you.
Give me a quick mo. Okay, you know what? I got a lot of things running on my internet right now.
Yeah, I don't know about the rest of you, but Jeopardy's theme is what plays in my head in interstitial moments like this.
All right, welcome to Name That Moon.
Right. As usual, like most of our trivia, this was multiple choice. So,
First question, which moon is this?
You know, I haven't the faintest clue. Oh, it's Enceladus, which orbits Saturn.
Is it Enceladus or Enceladus?
Enchilada. I don't know why. I thought.
Well, whatever it is, it's pretty. So, what is this moon?
Very distinctive. Callisto, which orbits Jupiter and is one of the 4 Galilean moons. Hint, you're going to see the other 3 later on.
What is this moon?
I don't know, but it's pretty.
Oberon.
Oberon.
From Uranus.
Yeah, one of the Shakespearean moons. He didn't discover them. They just decided there were so many of them, they could name them after characters from A Midsummer Night's Dream.
Just from Midsummer Night's Dream? Wow. Also, there's a player in my D&D party named Oberon, so I'm starting to realize where the name's coming from now. Oh, that looks more like an asteroid than a moon.
So it's probably, I was going to say it's a moon of Mars, but turns out it's Hyperion, which orbits Saturn, named for one of the giants, not the Titans, giants.
Next up, we got this pretty little thing.
Oh, I know what this one is.
Oh,
we're gonna visit.
Oh, it's Europa.
Another Galilean moon. I don't know when we're going to visit it, but it's going to be sometime within the next 2 decades, assuming all goes.
They've got the Europa Clipper mission planned sometime in the next couple of years to come go visit. What's this little dinky thing?
This has to be a Martian moon.
Maybe. Oh, it is. It's Phobos, one of the moons of Mars. So plenty of Mars this month. Oh, we got another one here. This looks like a cookie to me.
Looks like he's got chunks taken out. Jeez.
Yeah, somebody stole all the chocolate chunks of my chocolate chunk cookie. Oh, it's Miranda from Uranus.
Another Shakespearean moon.
Is that where that name comes from? Wow.
Oh, you know what? That might be from The Tempest. So it might be The Tempest and A Midsummer Night's Dream. There probably weren't enough characters. You're right.
And this one is Ganymede. Ooh, one of the Galilean moons.
Yeah, it's bigger than Mercury, I think, if I'm remembering my astronomy correctly. Yeah, it's the biggest moon.
That's pretty impressive.
Yeah.
This one here. That's a nice color. It's Io, another Jupiter moon.
Churned by Jupiter's gravity. That's why it looks so virulent, if I may say so. No offense.
Virulent.
It's very cool.
Good word choice. Number 10, what is this moon?
We're also going to visit this one.
Titan.
Which orbits Saturn.
Wow. And so can you tell me real quick what's going on with us visiting Titan?
We're going to send a quadcopter there, or it's an octocopter, actually. It's a rotorcraft lander, like it says. And it's going to fly around on Titan and tell us what it's like there.
That is pretty awesome.
Yeah. And yeah.
I think that's it for trivia. Great way to end off the trivia. So thank y'all so much for participating. We'll be in contact with the winners as soon as we can and let you know how we're going to handle all that.
All right, I guess we should probably go through announcements one more time. So at the very least, we can remind you when you should be tuning into this channel next.
Yes, definitely. I definitely have that pulled up. Definitely still have that pulled up.
Like and subscribe. If you want to be notified, also, you can just click that button and then head out if you need to head out. But we have other things in the announcement slides that you should be reminded of again. Though you can also just rewind. I'm not doing us any favors here. Oh, there we go.
There we go. All right, so we're still doing trivia. Okay, we finished trivia, so we can skip that slide. Smash like and subscribe. Okay, we've covered that already. Skip that slide. Follow us on social media at AoT _BCS on Twitter and AoT BCS on Facebook and Instagram. Check out the website, AoT, which is for astronomyontap.org/events. And you can also check out the other Astronomy on Taps as well, a lot of which are also doing virtual events. So you will have Astronomy on Taps throughout the month that you can go and visit just through your web browser.
Right. Again, please tip your bartender, specifically the Grand Stafford Theater, our usual venue. You can Venmo at Jose-Quintana-20 and put Stafford Tip in the description so he knows what it's for. Please don't let the Grand Stafford go the way of the North Door in Austin. We would like to return to the Grand Stafford in the after times. So please support them and tip your bartender.
And if you want to help support us as well, you can donate to us via Venmo or Cash App at AoT BCS. And if you give us $15, we'll send you an AoT t-shirt. So it's pretty
like this one.
Wonderful t-shirt, I must say so myself. It's very soft.
Our next event is on the 3rd Wednesday of October, which is when it usually is. Well, third Wednesday, not the third Wednesday of October. And this year, that is October 21st at 7 p.m.
Yep. And that's all we got for tonight. Thank y'all so much for joining in. And quick shout out to Carbon Queen's sister for designing the logo and t-shirt. So keeping it in the family.
We love our space traveler.
We love our space travel. Thank y'all so much. Have a great night and make sure to keep supporting your local astronomers.